Good afternoon, ladies and gentlemen. May I ask you to take your seats? We'll get started, yeah, sir. Close the door. Yeah, welcome to our breakout session on distributed AI for telcos. And a lot of people have asked me, why to hell do you include the distributed? So it is natural. So if you compare the situation of the big AI clusters today with 4, perhaps 5 important players, yes, they build highly centralized systems. When it comes to the telco domain, globally, with all their access networks and aggregation networks and metro networks, it is automatically a distributed system. Whatever we do, it is more distributed than how most of the AI jobs are realized today or executed today. My name is Andreas Ladisch. I'm from Deutsche Telekom in Berlin, and I have the pleasure and the honor to moderate this session today. The goal of the session is to have an open discussion. Where does the industry stand? And where does the industry stand? And also an open discussion, what are the next steps? What are the steps needed to bring all those AI capabilities closer to implementation in operator networks or telco networks? And there's also a motivation from TIP's side for sure. We think about starting a new project group dealing with AI for telcos or with distributed AI. And just as a starting point here, we want to consider this and run this session and sense what does the industry think, and could there be something where TIP can contribute, or is it better we step out and say, hey, there's something, there are enough organizations and that they can do it, which is presumably not the case. Yeah, so the session is structured like that. We start with a plenary, with a keynote presentation from Cristina from Intel, followed by a first round of panels discussing more the general question, what can and what does AI for telcos mean from the perspective of internal applications and out. I have it here. And then a second presentation from the operator view given by Jochen Appel from Deutsche Telekom, and a second round of panel discussion more with dealing with the question, what actions are needed, what do we need to do? So now let's start the session, and I would like to ask Cristina Rodriguez on stage. She is, now that is crazy, this machinery has switched off. Now I cannot introduce you. So Cristina is Vice President in Network and Edge Group and General Manager of the group's Wireless Access Network Division, and groups means Intel. So welcome on board, on stage here. And the stage is yours.
It's a pleasure to be here.
Yeah. And this is the clicker, as I guess green and white self-telling.
Is this working? Because I like to move fun. Yes. All right. All right. Okay. Humanity is forever interconnected to technology. As we go and look, and this reflects how computing is impacting our lives and the modern times. Everything today, everything in our life is getting more digital. Communication, entertainment, medicine, manufacturing and industry, social experiences, you name it. Everything is more digital. And as the impact of computing and connectivity evolve, so evolve the way we live, the way we work, the way we play. Today, AI is driving a generational shift. is becoming more of our life. It's driving a rise of expansion of opportunities where computing is even more foundational to our life and to the making of a better world. We're reaching an era of what we're calling silly economy. This is a term coined by Intel CEO Pat Gelsinger in our innovation event last week. It basically means that we're entering an era of economic expansion powered by the magic of silicon and software. In this silly economy era, AI is everywhere, from client to edge, network, cloud, and it's accessible to every workload, including radio access network workloads. We must embrace this new era. We must work together to create and deploy all these new opportunities. And we must embrace the democratization of design, unleashing innovation through heterogeneous building blocks over standard interfaces. That's why we must virtualize the RAN and open the RAN. By virtualizing the RAN and open the RAN, 5G operators, or the 5G networks, operators will be able to expand the range of control of the network. And they will be able to derive significant TCO benefits from performance and power optimization. Take, for example, dynamic network configuration. With AI, we can do hardware allocation through software-driven resource allocation. And by doing that, operators will be able to right-size the network in real time. With AI, we can have a higher granularity of control on power management. Things like voltage control, frequency, dormancy, of course, can be automatically adjusted. Traffic steering with AI would allow to balance traffic across multi-cells, being able to deal with capacity and coverage needs and issues, resulting on better user experience. Spectrum can be more efficiently managed, again, resulting in performance and reliability benefits. And AI is not only about reacting to the ever-changing network conditions. AI is also about predicting what is going to happen in network and taking actions depending on that. Network can be more secure by being able to detect and correct anomalies again on the fly. And network slicing, our favorite, everybody's favorite use case. With that, with AI, operators will be able to generate new revenue streams by having customer-specific SLAs, AI-backed guarantees, again, for performance, reliability, and latency. And finally, as the RAN evolves and scale and we bring AI into it, we'll be able to define the network as zero-touch automation, our ultimate use case. In line with the Intel vision on AI everywhere, we launched maybe a month ago, a new generation, the 4th generation of Intel Xeon scalable processors with vRAN Boost. This is a processor designed for high performance, high efficient, AI optimized radio access network. For the first time in the industry, you have a processor with fully integration of all the acceleration needed to run the entire RAN workload, all the way to layer 1. eliminating the need for any external acceleration. Everything can be run on the CPU. And by doing that, not only we reduce the system complexity, but we also increase the efficiency, reduce the power consumption. In fact, with this processor and VRAM boost, we can double the capacity with 20% of reduction in compute power consumption. Basically, more than double the performance per watt. This processor also has AI built in. That includes ISA extension, specifically to run AI workloads. It includes deep telemetry technology. It includes software drivers. It includes tools. Basically, the idea is that you can run everything you need in AI on the RAN without having to add any external component, any external GPU that will inevitably consume more power. As we look at AI, and AI, we're early in the journey. The AI workload complexity will continue increasing. The models will continue get perfected. The algorithm will continue having breakthroughs in innovation. But as we go through it, one aspect that we need to take into account is where are these models going to run? And there's a few considerations, a few key points with respect with that. Number one, and probably more important, latency. So if you have high demand on latency, you want to run these AI models probably in the DU or the RU. Another consideration is the frequency in which you have to run those models. If they're infrequent, then you probably want to have it centralized, so you don't use local hardware or distributed hardware resources. Another consideration is the software stack interaction. Who is giving the inputs to the model? Who is controlling the model? And last one is the availability of resources, hardware resources. Ideally, you want to run all your workload in the same place where you're running the rest of your RAM functions. That will give you the lower latency, the better performance, the lower power consumption. And because the workloads are complementary, you can certainly run both in the same CPU, and you can do smart things such as running models when you have a low traffic pattern. There's already operators deploying AI in different levels, different places. But the interesting thing is that we continue seeing companies breaking through and bringing really good innovation, really groundbreaking innovation. And I have a few here. Capgemini, one of the pioneers in this area, have applied deep learning technique into their Mac scheduler and seen significant improvement on the quality of experience. They have also some energy use cases in AI applied to energy where they can predict and take actions with respect to that. Tiero, we did a proof of concept with Tiero. They have an XApps focused on, again, energy efficiency and energy savings. Great results there too. DeepSeek have been around for a while. I think we have it in the panel too, yes? And they are they're taking standard layer 1 algorithms and replacing them, channel estimation, equalization, replacing them with deep neural network algorithm. And again, seeing really good results. Aira, another company, they are seeing dramatic improvement also when they use their channel estimation, prediction, beamforming, and they're also doing some specific to energy efficiency. And Ericsson, we demoed this at MWC in Barcelona. We worked together with Ericsson to use our power management techniques and capabilities in the CPUs, in our Xeon processors, and they saw, it's called CS states, and they saw we saw a 20% of improvement in compute power. So something significant. And then Microsoft, They are working on an analytics insight program that will, again, be used using telemetry and using the capabilities of our CPUs. It will result in an optimized network. AI is transforming dreams into reality. AI is going to be a game changer. It's going to be a crucial technology for the future generations of RAN standards. But for all this to happen, we have to have a cloud-native, fully virtualized, software-defined, open network. And the operators need to choose the right technology underpinning that architecture. We need a platform that is ready for innovation today and that is flexible and scalable to grow into the future and has the tools and the software and the ecosystem to support it. AI is making possible to push the boundaries of what can be accomplished, creating solutions for the most challenging world problems. And by doing that, improving the life of every person on the planet. Thank you.
Yeah, Cristina, really thank you for this inspiring keynote on, I would say, one important application of AI in the operator's network. And that brings us exactly to the topic of our panel discussion now. So I would like to ask you to join us here for the panel, and Manish and Elad and Steve. So these are, as you like. It could have been that easy. You are right. Yeah. So here's the pedal set. Almost in the right order. So that, and even without AI, isn't that great? So the first round is, yes, AI for telcos. What can telcos benefit from? We have already heard from Cristina, okay, open RAN is one important area. So networks are much more. So my first question is, what do you expect? What is the main interesting, main burning area where the operators can benefit from applying AI in their networks? And I even may ask you to, when you answer, to just introduce you to the audience and where you are from, and then I would like to start with Manish.
All right, thank you, Andres, and good afternoon, everyone. Manish here with Dell Technologies. Truly a pleasure to be here. The question on where the operators can benefit from AI, I think that's a very broad question, and in a way, I would say the underlying question in there is what area they would not benefit from. And I actually think there is hardly anything that I can think of. I mean, honestly, I think Cristina gave a great talk about AI and what that means in the RAN. And just in the RAN, clearly, from layer 1 to layer 3 to network level optimization, operation, AI is going to play a big role. But that's just the RAN piece. Then start to think of bringing that into the core and maybe more end-to-end in terms of whole network automation. We talked about a little bit about fault prediction, fault analysis, closing the loop around that. AI is going to play a big role in there. Just on that journey, start to think about what AI is going to do in terms of field support, field operations. And this is where I'm now trying to bridge into Gen AI. What does large language models mean? And how do we need to start thinking about context-aware enablement of field support teams so that when they are going out there to troubleshoot and figure out context-based guidance being provided. Same you can extend in terms of actually deployment. That's on one side. Think about from a customer support, marketing perspective, what's possible. So I'm going to stop because I won't continue, but the point I'll leave it is, it's going to touch everything from networks to operations to customer services to customer acquisition, marketing, reducing churn, on and on and on, because it's a technology that brings massive capabilities. Operators are sitting on massive data sets. There's tremendous value logged in, and honestly, we've not even started scratching the surface. It's a lot to do.
Yeah, so thank you, Manish. Hand over to
Sven. Sven van der Meer. I work for the CTO of our global telecom business in VMware. And to your question, what's the main thing? That's always the tricky one. What is the single point made? Well, I think there's three things. A, you can save money. B, you can make your customers more happy. And C, you can fulfill promises that telecoms have given people for a long time. AI might help you with all three of those. Saving money, I think, is an important one for you as an operator. So I saw in the keynote was energy saving, telemetry. With ORAN, you said closing the loop. We can have AI models in there, or we can have AI in there supporting a closed loop operation that actually helps you to save OpEx or energy. It's 60% of your expense and CapEx or an OpEx goes into the RAN. So if you can save money there, that's actually very helpful, right? And we're trying to build platforms where we're actually building this in. So this would be the internal platform management where products use AI to optimize our products to help you with your cost at the end of the day. You can get happy customers. Well, if you find the right use cases and services that you can expose to your customers that are AI-based, then you can actually bind them much closer to your operation, right? And these use cases are, if you go out and ask the people, what do you need? What is it? What's the thing that actually is your stuff? We have done this in the OGA, Open Grid Alliance. We have a booth here. So we talked with the CIO of Las Vegas. And one of their use cases was they have people walking to the strip and they want to prevent these people walking actually on the road getting killed at night. Can you help us? And we're using Chuch AI actually with cameras and a 5G network, channeling this into a data center. Chuch AI is detecting someone is walking on the street. I couldn't dream of that use case. I would never have come up and say this is something useful, but the customer said this is something that we want to do. And we built it for them and they're very happy with that. And then there's plenty of promises from the past, information access anywhere, anytime, any form, that you can now actually probably realize. So these three things: save money, make happy customers, and fulfill promises.
Thank you. And the last in the round is Elad.
Hey everyone, Elad Blatt, NVIDIA. I think I really like the answers because they're doing my work for me. They just counted everything. I would say it's probably what's hurting you the most. Meaning when we sit with CEOs or with teams of telco, we ask them, what is your biggest problem right now that you're trying to solve? Some might say, my OpEx are way too high. I'm paying too much for this transaction, this system, that system. Some might say, I want to understand how I can serve my country better. How do I maintain data sovereignty? How do I offer security services? So as Manish said, it's almost everything. And as Sven said, it really depends on, are you saving money? Are you making money? Are you trying to solve a specific problem that's hurting you? And based on that, you can decide which AI journey you want to take, or at least which AI journey you first want to take. And after you took the first one, it will be much easier for you to take the second and the third, and really get your hands dirty in how you go about solving problems using AI.
Yes, thank you. Cristina, do you want to add, in addition to your presentation?
Yeah, I'll be... but first of all, I would say I've been spending the whole event agreeing with Manish on every panel, so this is not different. I'm agreeing with Manish, I'm agreeing with Sven, and I'm going to agree probably almost on everything, but not everything with you, but almost. But I think one thing we all can agree is we have just scratched the surface of the possibilities here. I think I agree completely that the future AI, and AI running in a fully virtualized open network is the future, is progress. And at the end of the day, what needs to happen? There has to be TCO It's the total cost of ownership, but really total cost, including the CapEx, the OpEx, the time to market, everything else, and then the user experience. And that's where, that's where we're going to see the significant impact of AI, the total picture.
Yeah, so there seems to be a mistake if all the panelists agree, so we must perhaps think about the next panel. But great, great that you have this experience.
If you want some argument, just ask how.
Good. And with whom? Yeah. However, so there seems even a kind of hidden agreement that ORAN and the RAN is the right first step. And so now I take the operator hat. So if I consider the distribution of our traffic demand, the traffic load, and even distribution of the revenue, there are other areas of the network that contribute significantly to the revenue. And that might be easier to start with. So what is the reason that more or less all in the panel seems to have an agreement to start with the RAN side and applying the AI in the RAN? Is it the advanced architecture and that there are a lot of things that you need as a prerequisite are already sorted and in place, or is there another reason?
I'm going to start.
Yeah, please.
I think part of the reason is the RAN workload is very demanding. You have to have a solution that is highly performant and that doesn't consume a lot of energy. It's performance per watt in a very complex workload processing where there is signal processing, packet processing, and bit processing. It's highly complex. So and with a really, really demanding also reliability and security and trust on what is happening. So I mean, it's perfect. You have a complex problem. You need a deep technology, a intelligent technology to make that easier to implement and easy to deploy, and be able to solve the problems that is given us. And we have an opportunity how, because we're transforming the network on a software-defined based network. Now we have an opportunity here to use that to make software blocks and software modules that can alleviate and that can improve the network performance per watt.
Yeah, I mean, can I just add to that?
Please,
right?
please.
So I'll give you the good news and the bad news. The good news is, and why this always starts with, or why you heard a lot more around Open RAN or RAN in particular. The good news is there is an architectural framework that the industry has agreed to, and that helps. And that helps in the sense, what I mean is, the architecture itself introduced things like RAIC, near real-time, non-real-time, XApps, RApps. So the architecture itself started to give the basic, what architecturally is needed, what's possible. In other parts of the network, that has not necessarily been done. So that's the good news. The second good news I would say again to the previous panelists' comments is clearly RAN is a complex workload. It's obviously the biggest part of the CapEx spend. It probably is the biggest part of the OpEx spend. So naturally, things are gravitating in the right direction to say, if we solve for this, this is where we get the biggest bang for the buck, right? The bad news is this. There's a lot of work I still think that needs to get done, especially in places like ORAN Alliance, to get the interface specifications put in place to really start to catalyze this whole ecosystem. And what I mean by that is, even if you look at things like what's going on in work on defining the E2SMs and all, it's been really slow. Whether you look from the use cases to interface definitions to service management, I mean, that whole piece has been slow, and it's slowing down the development and adoption of this technology, number one. Number two, I would completely agree with Cristina and emphasize that the right architecture and the underlying building blocks have to be right to really catalyze this ecosystem. And this is why all this discussion that we've been having for the last 2 days in terms of disaggregation and putting the right plumbing in place is critical. Because when I go around and look at the ecosystem, I meet a lot of innovators. Some good startups that are coming up have great ideas on, hey, I can improve channel estimation. I can do better in terms of energy sustainability, reduce the energy bills. But if you look at those startups, their go-to-market paths today in those legacy architecture monolithic systems are blocked. So for this ecosystem to be catalyzed and for the operators to take advantage of that, it is absolutely critical that we start to disaggregate open and do more work in the standards bodies to clearly define the use cases and the interfaces.
So you wanted a panel that doesn't agree all the time, so here we go. Don't do O1, right? I'm not agreeing with O1 for the moment. Do something where you can measure the success of the AI you implement. O1 is relatively new. How do you measure success in O1? In energy saving I can do because I know what my energy costs are, I know what my energy is. I put this on a different base station, then I see what is that. That's really good. Everything else is so brand new. How do you measure your success for using AI in O1? Where you can relatively easy do that, most people who build networks, own networks, run networks, is configuration. Configuration management. Build a Helm chart. Get a team together who has no clue about AI. Get someone to help you, be it OpenAI, be it Microsoft, whoever you want. Train that team to actually build an AI application that spits out Helm charts for your configuration of your K8s. Works. We've done it. 40 people in my office went into a 3-day workshop, 3 different teams, all sorts of different use cases that we have discussed. My team ended up with doing exactly that. Have ChatGPT, Bing GPT, actually giving us Helm charts while we gave it the configuration we wanted. Directly, immediately measurable success. Because we can use that Helm chart, which we did, and put this in production and it works. It did work after 3 days. The first one didn't, so that actually crashed the system, but after that we had directly success. And we had 10 people in the team, 3 days workshop, they all knew how to do this after. They can go all work out and do more of this. So you start small, you use something where you can measure your success immediately. You train your people while you're doing this, and then these people can go on and do bigger things or larger things or different things. And it doesn't have to be O1, it can be O1, right? Not saying you shouldn't do this, but measure your success when you do it. That's important.
Yeah. Elad, do you like to add some points?
I would say that why RAN? Because as Manish mentioned, a lot of money is spent on RAN. At the same time, 5G utilization hasn't proved itself. How do you utilize on 5G? How do you make money? So most telcos would tell you they're not making money on 5G, not currently. So it's costing them the most and not returning the investment. So how do you solve that problem? You have 2 ways. Find ways to utilize 5G and reduce the cost of 5G. So those are the 2 paths that we need to take, and fortunately, AI could help with both. So that's my take on it.
Great. So first learning is we must look for the area with the highest impact. Okay, that's obvious, commercial impact. But there are also technical and architectural prerequisites that presumably can be solved best from the ORAN or the RAN architecture. So because we have this kind of standards in place which we don't have in the domain of other network areas. What we have not discussed up to now, and that will be the last round now, unfortunately time is running, but it's so inspiring. What we not have discussed so far is how, let's assume we have all these fantastic new capabilities as operators. So we have talked a lot about improving the more or less traditional services. There might be options for new services. I think one of these inference services was mentioned. So that is one direction. So what is your view on this kind of dual use of the potential infrastructure? Do you expect that there is an additional lever to go in that direction and to utilize that, or what do you sense in the market already? Who wants to start? Manish?
I can take a stab and share my view on this. So I think there was a good example given earlier around video and video as an application of, hey, here's a use case, there's a video analytics happening, and it's making some decision. It's inferencing and making some decision. Now, that use case can be broadened from safety, security to what you might be able to do on a industrial floor, etc. But the point is this. I think to the question of where you do the training, I think that to a large part is pretty clear. You go train in the big cloud. But inferencing is where the opportunity starts to open up, and here is why. You can have two ways to implement this. Take all that video, and as again was said, hey, we're going to send it all that back into the cloud, and then we're going to do some analysis there. Yes, you can definitely do that. That works, but when you start to continuously scale, it doesn't necessarily scale very well or scale inefficiently. There's a more efficient way to start to do that, is where the data is getting created, and I'm using video as an example. You can take all the other examples of where you can start to apply, leverage the data, do the inferencing, create the insights, actionable insights, and action on that data. And the more you can do it out and about where that data is getting generated, that's the opportunity. Now, how do we get there? And to your question in terms of does that create new opportunities for the service providers to provide, to generate revenue streams? The potential is there. Can the service providers move in that direction and seize the opportunity? That remains to be seen.
If I may add to that, I think that Manish touched on a very important point, and I'll build on what I said before. If 5G is expensive and 5G is not utilized, you're losing money. So if you can take the same infrastructure that you use for 5G and now work on that infrastructure to give AI services, some that you can use internally, some that you can sell, you're actually getting the money back, 5G for free. And which means if you allocate some resources in the same system, as Cristina said before me, if some of the time it's 30% utilized, 20% utilized, what happens to the other 70%? If you can utilize that 70% to generate revenue for you or to generate any sort of savings for you, you're getting that money back. So that's the key, whether it's video inferencing, whether it's any sort of machine learning or even LLMs. The future is the ability to get high utilization out of every single compute that you deploy, whether it's in the cloud, whether it's on-prem, at the edge, or anywhere else.
Just following this one, the important part then is to go out and do it. Like go out and co-create, find like-minded people, find companies that have an understanding of a particular market, of a particular wish. Find people who are actually on the ground already, who have the dirt work done, right? Go co-locate, build your edge out, because usually you want to have the AI where the actual people are that benefit from the AI, or where the data is created from people that benefit from AI. Don't put your video stream and send it across the world. That doesn't make much sense, except for proof of concept. But you have to go out and actually do this to understand what the impact can be on your side. There's no point in discussing it or doing PowerPoints and Word documents. You have to go out and actually do this and see what is the impact that you can create. And sometimes it is that a technologically very trivial solution and easy to build, like Deutsche Telekom, right? You have tons of experts, has a massive impact. And then you can turn this around and probably generating revenue from this, right? Because if it's impactful, then usually someone wants it, and then you have a better sales out there. It doesn't have to be the massively big system that takes 3 years to build and 10 million before anyone sees what it does. Go out and build small things. Go out and do it. I think that's really important, and builds the expertise inside your company on how this works.
Did I mention he's my new best friend?
I can imagine.
I'll add on a little bit. I'm going to pick on what you started, Sven. I think the one thing that I like what you're saying of let's go and do it, and the reason I like that is because first of all we have a lot of companies having a lot of new innovation breakthrough. By the way, I forgot to mention Canonical, but you guys are doing good stuff on ML too. But a lot of companies doing innovation, proof of concept, but we have to go and bring that into deployed and integrate it into commercially available networks. And the reason what I wanted to say is that what is important and what is key and good news, talking about good news, is that the technology to do that exists today. We have a platform, and I'm going to say a platform with our servers from our partners and Intel Xeon processors that can run the workloads, the AI workloads today. That can do, by the way, I don't know if you know this, but the staggering majority of inference in the world is running on Intel Xeon processors. So you have the technology today, and that's what we're trying to do in Open RAN and vRAN. Let's go ahead and do it, and it will be a small scale of what is going to be available in the future, but we have to start, we have to go and make it happen. We have everything that we need right now.
Thank you, thank you. Great, so in very short summaries, we have to choose the area with the right architecture that fits best to what we can do with AI. B, it must be the right area with the high commercial lever. C, and we have heard that multiple times now, do it now. And start now and don't wait and experiment. So really thank you for this first round. Thank you, the panelists. Big applause. and that brings us to the second round of our breakout session on AI for telcos. And the next part is a presentation given by Jochen Appel from Deutsche Telekom, who is Vice President for Automation at Group Technology, one of my colleagues. And it is so obvious to make that. So he is the poor guy now to fight against the fact that we lose money with 5G. So that was mentioned that often. So welcome on stage, Jochen. Hey.
Thanks, Andreas. Hey, you already stole my story, actually. You know, like how to make money, how to be more efficient. Yeah, good afternoon. It's a pleasure to be here. Jochen Appel, I'm with Deutsche Telekom, as Andreas said, Group Technology, responsible there for automation. And this already gives you an idea how I look personal from my role at data and AI. And I would like to today give you a kind of a high-level overview how I look in my role at AI. I called it AI at scale, where we are at. So the situation we are currently in by using AI in today's business, but also the challenges we see, how to move forward to use AI at scale. And I would like to end with some proposals of areas we need to address as an industry. That's my personal view. That's shared with many colleagues, with many peers in the industry already. But it's kind of an input for a broader discussion on how do we actually realize across the multiple layers, how do we lay the foundations for AI, using AI at scale. So without further ado, I would like to run you through this. It's not even a keynote. It's a small pitch. It's a small pitch for the actual discussion we are going to have. And I do not read out these data points loud. I do not read them out, and I do not read out each and every of the market opportunities we see. I think the question is not where do we use AI? The question is where do we not use AI? I don't think, as Manish said, there is a single area where AI will not play a role in transforming our industry and many other industries. And the right side also gives you an idea, what we will also touch on later, which is we look at it from a dual use perspective. So we not only have use cases, strong use cases inside our network operations, network planning and operations, but also, of course, at the same time with the next invest cycle, we obviously look at how can we use the same infrastructure, the same methods, the same paradigms to actually serve our customers, B2B consumers and others. So that's, of course, an important thing. Now comes the big the big but. So today's era I would call the opportunistic era of AI. What do I mean by that? So if I look again at my own area of responsibility across the value chain, planning, building, and operating of networks, that's what we actually do. Yeah? If I look across these use cases we drive, and I have been driving over the last 18 months with my team, there's great things everywhere. You have great use cases, be it fiber planning, actually one of the biggest addressable spend areas of Deutsche Telekom. Yeah? 80% of our CapEx goes into fiber. Be it customer-related things, be it customer experience topics such as incident analysis, fast root cause identification. We have great use cases built there. We have built great automation use cases in our network operations for automated ticket resolution. We have energy consumption use cases. Everything is there. And then you go into, which is not my turf, you go into the customer conversational apps, great things there. Yeah? Would we say, if you're honest, and each of us ask ourselves honestly, is that using AI in your day-to-day operations at scale? No, it's not. And why do I think it's not, even if it's great? Each and every team you put on a high visibility use case, and of course you need the high visibility use cases because otherwise you do not have credibility with the board. So you need to do these things. Yeah? Get your hands dirty and drive those use cases. But what you find is each team goes through the same tedious cycle of data acquisition, feature engineering, model training, over and over again. And it doesn't stop there. The world is changing, hence data is changing, hence model is changing. If you do not have, and I will come to that, automated ways to do that, and offer a single pane of glass, data single pane of glass towards your business users who are actually supposed to work with those tools, we are not using it at scale. Because each and everything becomes a siloed, singular engineering type of thing. And it shouldn't be. It should be a platform, a product and platform-driven type of thing. So this brings me already to what is needed to actually build AI at scale. And to me, it's a couple of things. Some of them we will touch today. I will, of course, not touch today organizational issues, which we obviously need to make use of technology. I will not so much go into market-oriented things, but more in the technological things itself. And we created at DT what we call AI at scale strategy. And again, this combines with the getting your hands dirty approach. We drive our use cases, but we also think we need to address the technological layers and make sure the important components and points in the architecture are open enough to actually enable the layers above. It starts with infrastructure, which produces the data. It then goes on to the data layer, how to actually create an open data layer with open data exchange formats, with an automated way how to lifecycle data. And above that sits, of course, the MLOps layer, the machine learning or AI ops layer, where you have the same time of lifecycle and automation issue before you then are able to support your business organization with machinery, I talked about. And I'm already coming to the major, I would call, where I see the call for action, where I said what is needed to actually transform that approach of siloed, isolated things into a more platform-oriented approach. And if you go down, I don't want to go line by line, but I would like to cluster it in a couple of areas where I see the major challenges. One, Andreas already stressed, is the efficiency, which sits in the network itself. Yeah? So a lot of discussions I right now have with our board is around how can it help to drive TCO efficiency? How can we radically lower energy consumption? Yeah? And I'm not talking about 10%, 15, 20%. I'm talking about another step change in each dimension of TCO efficiency. Yeah? So, for instance, today we look around in network equipment and we see people say, oh, I have a piece of energy efficient equipment. It's steered by an intelligent algorithm. You go there and you ask, in an idle state when no load is on, how much energy is consumed, and it's 60% of the maximum load. And it's wrong design. Sorry, but it's a wrong design. It should be near to zero if there is no load on, right? That must be, even if it's not realistic from day one, but that should be the North Star of that discussion, right? The second area, or the second cluster of problems is around the deployment options. I want to be able to use hyperscaler clouds on-premises cloud technology and be able to flexibly run training as well as inferencing in both worlds. I do not need to have my own huge data centers with GPUs to do a lot of training. I would like to rent that, but the inferencing should be, of course, on my own equipment. Data privacy issues, I leave them aside for the moment, these government things, but we need to actually be able to have those algorithms, the mechanisms in place to be able to flexibly do that. I already mentioned the dual use, yeah? So it's not just for our own workloads, for our own AI workloads, it's also for our customers' workloads potentially. So the other parts I already touched, which is on the data layer and on the ML layer, the automated lifecycle management, yeah? Where the majority of steps from data acquisition through the pipeline all the way down to the model monitoring and lifecycle management are fully automated. And the complexity abstracted away from the actual user, which is the domain expert. These guys I need to solve domain problems and not to do data acquisition and cleansing. And the last thing is also a very important one, which is, I believe, in the standardization of the tech stack. What is it at the end of the day I want to control? It's the critical pieces of the infrastructure, it's the data, and it's the business question. We are not the company doing ML technology. We are not the company doing data pipelines and data meshes. This, the tech stack I call, will be standardized. And I have no interest in having a fragmented tool landscape, increasing the tool sprawl and tool fatigue amongst our people. It should be standardized on common things we have. We have hyperscaler partnerships in place, and we have one internal framework. So 2 major frameworks are more than enough to actually support the majority of ML or AI cases across the company. So that generalization of tools is a very, very important efficiency driver. And only in the rarest cases for highly segment-specific or domain-specific things, I would allow for a deviation. In 99% of the cases, my theory is, or my claim is, we should use a common pipeline technology. And I would like to end with this. Hopefully this lays the ground a bit for a great discussion with my colleagues. And yeah, Andreas, back to you.
Yeah, thank you, Jochen. So please join us for the panel. So I think you can take already a seat. Yeah, so that is hopefully a lot of food for thoughts for the second panel. Yeah, so our second panel will focus more on the question, what do we as community need to do to make it happen, to make it faster, to bring it into real life, and our panelists will give a kind of a starting statement, and I would like to ask Tim first to give a statement. What do you expect from would you expect from a community, but also to introduce your company first. So please, I can steer the clicker, or if you like, you can do it by your own. Okay.
Perfect. Thank you. All right. So I'll give you a brief overview. I'm Tim O'Shea from DeepSig. And DeepSig, we're really focused on leveraging AI within the RAN, and specifically for the lower layers, the physical layer, and optimizing the air interface and the wireless performance. And I think this is a very ripe area. There was some nice discussion earlier about the value of AI at the edge and in the DU. And these are the places where these are the cost centers and the drivers of 5G. And so if we can significantly improve TCO and efficiency today in 5G by using these techniques at the edge in the DUs and the RUs, this can have massive value. And I think so, our focus has really been bring this to market in the 5G space within vRAN and ORAN solutions where there's key areas that AI can improve performance. And then also in 6G, where a lot of these are going to continue growing. We're going to continue to build the AI stack further and further and further throughout the modem to make more and more pieces of the RAN intelligent. And so just wanted to highlight a couple key areas where I think that there's major impact here. And really all of these are focused on driving performance within ORAN. We were super excited to be recognized by NTIA as part of this award to look at ML and generative AI for measuring the air interface performance using kind of generative techniques, which is, I think, a nice example of generative models beyond LLMs, where they're obviously also very transformative in many other applications. But marrying this ability to do generative models in kind of this digital twin where you're modeling the air interface, the propagation models, the user activity, all of the patterns of life of a network that you need to optimize for. When you pair this, and this really does go to the theme here of how do you scale AI, right? We need this data continuously gathered from the network, from the RAN, from the air interface, up into these RIC apps where we can build and continually refine these models for the world. And then we can use these to tune things like the DU algorithms that do our receivers, that do our massive MIMO channel estimation, that do our multi-user scheduling and our beamforming, because these are the places where we can exploit all of this data to drive the spectral efficiency and the energy efficiency of our networks to really help directly impact the factors of TCO. And then lastly, I think looking at spectrum awareness is another big aspect of this, where at the edge, if we can start to use things like AI to understand the activity in the spectrum all around us, we can help to improve higher density, easier coexistence of private 5G networks and future spectrum sharing methods that we may move to after CBRS, as we need to pack more networks more tightly together and get better spectral efficiency as a society. So I think these are kind of some key enabling technologies, and they fit really nicely into this Open RAN stack to really help it scale and drive the TCO in 5G and beyond. So thanks.
So yeah, please take a seat. And then the next panelist will be Mariam Shevik from Nokia Bell Labs. You want to give a starting statement about what do you expect that from the ecosystem and what do we need to be faster? Please, the microphone for you.
So I was told not to prepare slides, and I was actually going to say I don't need an introduction as Bell Labs, but I will take the time, a few minutes, to basically give a brief overview about what is happening in Nokia and Bell Labs. We are covering the whole stack with everywhere, in every single aspect. As Jochen pointed, we are applying AI for sensing capabilities to deal with data, for predictive capabilities, for analytic purposes, for decision-making purposes, and have here and there a lot of AI ops. But I do believe that, Jochen, you pointed to a very, very important point. What is the holistic approach so that we can really scale AI solutions, not only in one specific domain, that we can repeat and replace and reuse certain models for that specific problem, but how do we really operate, manage, design, and compose? Configuration was mentioned in the previous panel. How do we really achieve this full autonomy in the network that is capable of making decisions and predictions about what technology will be applied for which intent, for which service inside the network, but also for the end users. And that requires a lot of collaboration, a lot of partnerships, a lot of also discussion on what needs to be standardized. I would not say everything has to be standardized here. However, the key KPIs, the key APIs, apologize, have to be agreed upon. And that is another challenge that we have to look at. You mentioned public cloud usage. There is not only one provider, and APIs, only in that sense, is already the management of them and handling of them is a complexity for itself. So that's, in a nutshell, I would say we need to touch. Thank you.
Yeah, thank you. And please forgive us the miscommunication concerning the starting slides, because someone told me you don't want to use slides. Okay, typical example of miscommunication. I'm really sorry. So, next one in the panel is Elad, and he has prepared some intro.
Actually, I don't plan to use them.
Oh no, that is not fair.
Thank you. So I was going to use them, but then I listened to Johan, and actually you can just skip them. Because I was listening to Johan, and I understood that the problem is different. And I think that I've got good news for you. And the good news for you is that we have a full Lego set. And the Lego set is of all the components that you need to make that happen. You've got Dell with the machines. You've got VMware with the platform. You've got Ubuntu Canonical with the orchestration layer. So you've got all the Lego sets in this room. And each and every one of them has a few more that they can bring. You even have GSIs that can bring you LLM models for telco that you can share. And I think the problem that we need to address is when you got a Lego box when you were a child, there was always at the back a few things that you can build with those Legos. That's what we're missing. We're missing examples of how to build those Legos into actual cool things. And I think that's what Tip and we can do in this room, start this journey of building those models for telco that make sense in Legos. And I think that's only a small step, but it's gonna get you to a lot of what you pointed out.
Thank you. Yeah, so that brings us back to the question. So, how can we accelerate the development? What is the right approach? So we learned, okay, Lego, standardization, that was Mary mentioned. Jochen talked about the exchange of models, also a little bit like standardization. So how can, or what can ecosystems and what can organizations like TIP contribute to bring that to a level that it can be used by the operators? So what do you expect there? What is missing? You say everything is there. So yeah, that somehow it seems to be the case, but on the other hand, there are still some blocking points. So what is that?
Can I start?
Yeah, sure.
Okay. A couple of things are missing. I think we have all the Lego building blocks, the majority of them at least, and new building blocks are coming up. If you look into academia, a lot of research is happening. A lot of research is also happening in organizations outside the telco industry, such as OpenAI, to name one example. So in the AI community, there is also a lot of innovation happening. But one missing piece there is, for example, and I talk here as somebody who has spent 5 years in a computer science institute that is very strong in AI and in a wireless research center that is very strong in the RF and PHY layers. They don't talk to each other. Sitting together and telling the AI community, that is my problem I want to solve. Do you have a tool for it? Or can we develop something together? The domain knowledge is on the one hand side there, we know what the problems are, but we are thinking probably too conventional, not very AI driven. the way we are applying AI in most of the cases, and I'm here not talking on behalf of Bell Labs because we have our own AI lab and do our own AI research, but generally speaking, we are borrowing these tools from the AI community and apply it to mostly known problems in telco networks, where we can say, yes, we can evaluate and validate the results ourselves. However, I do believe if we had a very mixed community, and we see it here in the room and in the panel, it is very mixed. Sitting down together, really bringing on table what are the Lego blocks, the building blocks we have, the Lego pieces, as well as what are the sets of problems and how can we match them. If you look into game theory, there is actually matching games, very simple, and both sides can be just theoretically on these algorithms be satisfied. The AI community would have their problem, their use cases, and we would not had to, in the telco world, think really about certain search for tools, but had more tailored approaches and models.
Am I allowed to add one question to that point? So, because I share that observation. So there is a lack of communication and exchange between this AI community, the guys who really understand this machine learning toolbox, and the guys working on networking. My second observation is, and I'm not sure whether you would share that, so that's a question. There are even so many different, highly complex domains in networking. So submarine networking or fiber networking is something different than radio access. So, and isn't that something that may create additional hurdles so that we have this super domain-specific data, domain-specific knowledge? So, and how would we approach a more generalized, or how would we create a more generalized approach to that?
So it's a very good point, because I think I'm a little bit spoiled there, as I can talk to the submarine people, the optical fiber people in my team. I can talk to fixed access, radio access. So I have this diversity in my team, and it is definitely a platform thinking that we have to introduce that platform. But on the other hand, if you purely ask from the AI perspective, I do not think that there will be one model fits all for all the domains. That's never going to happen. So we might have to identify multiple domains, break it down into multiple problems, the whole network, even if we want to achieve it holistically. But then the coexistence, interoperability of these models in a holistic framework or heterogeneous network is another step to look at.
So, no, please.
If I may add to that, I think that, while I agree with Miriam, I think that part of what Jochen said before rings true, which is telcos do not necessarily want to train their own models. That's a very pricey, hefty price. But I think that telcos share a lot of the problems, meaning telcos between themselves share a lot of the problems. So if you come together and do the training together and build the base models, the foundations together, and then take them internally and do the additional p-tuning with your own data, meaning the p-tuning is done per your data, but there's already something general out there. You're saving a lot of the costs, you're sharing, and this could be done on multiple levels, whether it's RAN, whether it's operations, whether it's any of the instances that we spoke of. Share the initial workload, and then the inference and the p-tuning do on your own. And again, tools for that already exist. I think to your earlier question, what's the biggest problem? Telcos are looking at the toy store at all the Lego sets and are not picking one.
Also, they look to the shop window, that's all.
Yeah. They're saying, wait, maybe a cooler Lego set will come out. Or maybe I'll wait till my friend gets that Lego set. I'll see what they did with them, and then I want that Lego set.
So yeah, that's, I like your picture with the Lego. And there's even a risk because, you know, Lego designs now all these special pieces that I hate. So because, but please.
I think on another level too,
they're not all going to be Legos, right? There aren't going to be AI models off the shelf from the AI community that are going to solve the problems we want. We need to look at this flood of fundamental research which has empowered computer vision and language models and figure out what are the key techniques and innovations that have really enabled these to scale. And then we need to go back to our caves where the DSP engineers live, building the basebands and these pieces of each core wireless or comms problem, and really exploit those fundamental techniques and weave them into the signal processing domain. Because it's not something we're going to throw over the shelf and hope a CS AI guy who's never done baseband processing is going to solve, because you really need to weave it into very low latency. Like we're building these tailored networks that can run in like 10 microseconds because you need to meet these super low latency demands in the DU. And this is not something people do in vision and voice. They're much higher on the millisecond level and things. So I don't know. I think you need to really bring it into the radio engineering and the comms engineering. And these are becoming the new tool sets that new comms engineers are bringing to bear on problems very, very quickly. I mean, like IEEE and ComSoc are starting to really focus on new venues and around this approach. And so it's really a shift in how comm systems are built.
Jochen, do you want to add?
Yeah, this thing which I brought up here, AI at scale, yeah, is a huge elephant, yeah? And the question always is, how do you start? How do you get it down to a first tangible problem you solve? And also then the next thing is, what communities and what other instruments can you use to solve those problems? And over the last couple of days, and this is great, I mean, I'm new to this community here, but over the last couple of days, I was running into many people who told me their approach to AI and networks. And I said, okay, what is the biggest obstacle you come across in each and every project you go into? What's the main thing? If you had one thing to solve, what is it? And you know what it was? Everybody told me, if we didn't have the data acquisition problem, we could be so much faster. So everybody, every single case, and that is totally what I told you before, what I experienced in my own examples. Everybody comes across this data topic, okay? And if I had one wish, what an industry, and I'm not sure if this is the community or somewhere else or a combination, but having places for, I shouldn't call it standardized, but having design patterns, best practices for open data models and also design patterns for automating these pipelines could be a huge accelerator for AI acceptance, because we all, and please ML engineers here in the room, don't kill me for that. We are all fascinated about AI and ML models, etc. But I mean, what are these guys, the ML engineer, what is he doing if he has no data? If the data engineer didn't do feature engineering with the domain experts, they sit idle and said, when can I start to train my model? Okay, let's find the right data. And that happens all over the place. So 80% of the effort I spent today is in data engineering and integrate. And then after we have the model and you deploy it, you know what? It becomes a systems integration problem. It's, again, not a machine learning and AI problem. It's a mundane IT integration thing. Again, having blueprints here, how to do that, having best practices in the industry, how to do that, helps enormously to accelerate that.
So if I may try to answer some of that, I think that you're absolutely right. I mean, you need the correct data and the accurate data for your model to be worth anything. But I think that if we learn out of the experience of people that already done this, data scientists do this every day. So you need to lean on work that has already been done by data scientists, how to refine data, how to measure data, and how to transport data. On the transport side, the hardware vendors can help you get the data faster, more efficiently. On the actual refining of the data, you need to lean into models that have been developed for other fields. And at NVIDIA, we've seen this time and time again. We started doing stuff for gaming, and people in data science saw that and said, hey, I want to do the same thing, I can use those models. And then people from healthcare said, hey, we have the same exact problem. I'm assuring you, you'll find the same exact problems in telcos, because when we speak to telcos about data acquisition, data structure, and then data refinement, we find that GPUs can help you accelerate that, And even more so, models already developed can help you solve that.
All right. Do you want to add one?
Yeah, I was going to second that. I mean, I think that one of the things that we found to help really accelerate us being able to build models for a lot of conditions is building these really high rate simulators that we can run on GPUs or large clusters to help train and make massively more augmented data, and then fitting this to the real world so that you have the match and you have the massive amount of data and the pipelines you need to do this to create these pipelines to continuously train and deploy the right models.
Yeah. So
to add something to this, we talked about a lot about openness, right? Open availability, open RAN, open this in this consortium. If we look into the AI community, they have tons of data available online, and nobody is questioning privacy, security reasons, because that's just very generic data from which models can be developed. One approach could be that such a community is created and agreed upon what database should be created for networks to train models on generic models.
Great idea.
Yeah, I think that's one I've heard before, and I think that can go a long way. Putting data sets out there can really help accelerate a lot of problems in fields. But it's also interesting to look at the differences in telecom, because if you look at language and vision, you have a kind of a data monopoly by many of the major players there, and so they differentiate on their data, not on their algorithms and their capabilities. Whereas in telecom, we don't have data monopolies nearly to the same extent. We do at some layers of the stack, but at many, like especially at the physical layer, these are things that are readily available from our systems, and the references are transmitted in every slot, and so there's no data monopoly. And so in that case, you have to consider, how will companies develop value in this space, and they're not necessarily going to be able to follow the same models that the kind of big data warehouses do.
If I may add to that, I think that's why I chose to do what I do. It's a painful job, but I think that telcos have the most data probably in the world. And in the edge of AI, data equals intelligence equals money. So all you guys have to do is figure out how to focus on what to focus on first and how to go about it, and your data will be worth money. A graph that I saw recently that really got me a little bit sad was the amount of data going through telco going up and the revenues staying flat. How is that possible?
yeah, so we still discuss the question how an organization like TIP or the ecosystem can contribute to or can accelerate the development and the takeoff of AI in networks. So and we're still at the point, okay, we start with communication, so between domain knowledge and the AI expertise, or teams with the AI expertise. So then we had looked from different angles of this question, how to make data usable for the community and make it accessible. So, and yeah, so let's do it and figure out how we can do that. Jochen, you want to add one point?
I'm not sure if I want to add a point. I think
the
most important thing, the most important thing has already been said. I think it's a great starting point to look at. Well, I gave you a challenge which we have is in how to scale it, and the obstacle data being the thing, how to actually accelerate here, the process around that. And I think the TCO efficiency, if from the list you have showed briefly, one thing stands out over the next years, it will be the TCO efficiency. And be sure, I'm a believer in the market potentials, otherwise I wouldn't have brought up the B2B potentials in these different segments. But it's a little bit further out until that becomes a significant item in our revenue. But on the TCO, there is really need for action. And that's, if I had one wish, we look into use cases, especially around CapEx efficiency, OpEx efficiency, smart CapEx, again, what I said in the short teaser. I mean, look at the look at the spend. I mean, and this is really, with all due respect, I mean, optimizing the runtime of the network is great stuff. I love it too, and it gives me also automation in my day-to-day operation. But look at the addressable baseline. This is like the core operations is like 10 to 15% of my baseline, and 80% is like infrastructure. And from a process perspective, it is plan and build, and not operations. In the operations, at 10% of my people, and plan and build like 80% of the people. That's where we focus on. That's why I mentioned the fiber scenario, where we focused. Everybody was asking me, Jochen, in the beginning, when I did the first Lighthouse use cases for the AI initiative. Why don't you go into the closed loop automation thing? Because that's fancy, right? Intelligent slice control and all that stuff. Fancy stuff, great stuff. But the first thing we did was something completely different. The first use case we chose was how to leverage geodata to be more efficient in fiber planning in Germany, okay? Which has nothing to do with runtime, which is a suite that helps my planners to get 70% plus more efficient, 70% plus more efficient. And with 3 million households per year we built, I don't have to tell you how much that translates into efficiencies. The same is true for energy in radio. Yeah? And those are this is how I look at it. Bring TCO down, leverage right now in this window of opportunity over the next 2 to 3 years, primarily solve this problem, do something around the data acquisition problem in these spaces, but build it in a way that it can grow into other areas as well. So I do not want to go through the same cycle again when I start to solve more and more of the closed loop automation problems, because then I want to use the data catalog I established for the planning and build phase. I want to use that same data for the other use cases as well. And by the way, sooner or later, I want to expose it potentially to third parties. The same data in a data product approach. Yeah? So build the use cases, get traction, but then build it in a way that it's reusable in other scenarios down the road.
So what you basically say is we should work on the use cases, agree between a couple of operators, not in a traditional way. So use cases, that resonates a lot with traditional standardization. That's not what you have in mind. But to agree on those use cases, understand the economic impact, agree. And
some of them are there. Some of them, okay. and we already talked in the ORAN community, obviously, about energy. That's the kind of a signature use case you see all over the place when it comes to the things I mentioned. You would find in this community, especially in the ORAN energy efficiency space. Yeah, all these factors I mentioned. But there is also fiber we have to think about. That's probably not something, you know, which is I'm not sure about TIP so much, but it's not a dedicated work stream here, I guess. But it's something we have to deal with. But find your use case and then build it in a way that it's actually what you built from a platform perspective is scalable to other areas.
Yeah, okay, so that is one question. So whether we focus more on this planning aspect in the initial phase of the rollout of systems, or whether we look at this different control loops in the operation. So both is possible. We need even to assess that. But you wanted to add one point here.
I would say that I think when TIP initially approached us about this, what we thought of was let's build blueprints together. And the blueprints are same hardware or same structure of hardware. They could be different partners, but same structure of hardware, different software, all programmable. And then the use cases, the blueprints would be for operational efficiency / planning, how to save money, then how to make money, and then based on workload and tenant, also sell. So I think that if we use TIP and the partners that we have at TIP to build these and to test them out, telcos will find it much easier to deploy and use these in everyday life. And again, once you build it once, it will be used for multiple use cases also as you grow. It could start with inference of one kind and turn into something completely different. But the main thing is to start. And to start is what I'm trying to push telcos to do.
Yeah.
Enter the Lego store and have fun. That's what you're saying.
Yeah, so it seems we should close the session. All of you give that perfect summary. However, I would like to ask one question. We discussed this dual use with the other panel. How important is this dual use for the commercial success? I would like to ask that question as well. So can we just start with the internal use cases, or is it important to have the dual use cases in any case from the beginning?
If I may start, I would say not dual, all use cases, or almost all use cases. It has to be a platform that you can deploy on-prem, in the cloud, multi-tenant, multi-cloud, multi-use case. Otherwise, it doesn't make sense. You're going to spend all this money, you're going to spend all this time training people, you're going to spend all this time working with the ecosystem partners. It better be the right type of structure to deploy across the board.
Fully agree.
I would also second it. And just to iterate a little bit on it, you said multiple use cases. And if we really start thinking about use case by use case, developing models for each use case, I think that might not be the right approach here. We have to generalize the problem a little bit. And then for individual use cases, we can have refined models. However, that's why I mentioned at the very beginning the intent-based aspect. Look at the use case from its intent perspective, then you can adjust it to the network intent, the service intent, the user intent. I think that is a different angle to look at if we really want to achieve this agnosticity or multi-X.
Yeah, so what I meant with dual use was the external and the internal, but you have given a clear answer on that. So what is the learning from our discussion here in the last 3/4 of an hour? So first of all, thank you again, Jochen, for giving this impulse presentation. And thank you for supporting all those questions and underscoring the importance of those questions and even adding some. So what is the short summary? Lego. Or a little bit longer, think platform and platform thinking matters, and enable the community to create this, let's say, data platforms. So, and help them to create that data platform so that the AI community can utilize that data. So that would be my little bit oversimplifying summary of our discussion here. So really thank you. It was a pleasure to have you here on stage. Big applause. Hope you can enjoy the evening and Fyuz tomorrow. Thank you.